to my talk first. So today I would like to talk about my taxonomic investigation on populations of mysterious Sidalcea that we found in the North Coast Ranges in California. So, where are North Coast Ranges? They are actually a section of the whole California Coast Range from the North San Francisco Bay Area to the coastal Humboldt County, which is this area marked as the shallow green here. And within this area, multiple populations of Sidalcea were found on the serpentine soils, and it's really challenging to identify those populations into just one single species. In the first version of Jackson manual, those populations were identified as Sidalcea diplocypha, which is a native species and is widely distributed in California. And it's usually found on serpentine soils as well, and it has a distribution in North Coast Ranges. However, after Dr. Hill did more careful analysis based on the morphological characters, he changed those Sidalcea populations to Sidalcea, which is another native species. And it was considered to be as an endangered species, and it could be only found in the southern Sierra Nevada foothills in the first edition, which is kind of weird. And even if you use those new keys, it's still really hard to identify those Sidalcea population into either of these two species, because most of the populations show kind of intermediate morphological characters between these two species, so it's really hard to define which species should it be. And let's look at what characters did Jackson manual use to describe these two species. So it basically focused on the following four morphological characters. First, for Sidalcea, they really have undivided upper pair stipules and bracts, and they're really shorter than calyx. Well, for Sidalcea diplocypha, they already have divided upper pair stipules, and they're really longer or more or less the same as the calyx. Second, for Sidalcea, they usually have middle lobe of the upper stem leaves divided with middle tooth more or less the same as the lateral tooth. Where for Sidalcea diplocypha, those lobes are usually either entire or with the middle tooth fairly larger than the lateral tooth. Third, for Sidalcea, they already have granular inflorescence and calyx, but for Sidalcea diplocypha, the inflorescence and the calyx are really not granular. And the last one, for Sidalcea, they already have not congested fruit inflorescence with visible axis, but for Sidalcea diplocypha, the fruit inflorescence are usually congested without any visible axis. So here comes to our research question. What exactly are those Sidalcea populations in the North Coast Ranges? Are those populations supposed to be Sidalcea or Sidalcea diplocypha? Or maybe they are the hybrids between these two species, or hybrids between one of the progenitors of these two species because they have some intermediate morphological characters. Or maybe they just belong to a new species that don't really know in the past. So that's the reason why we start our research. And I think it's really significant and interesting because we really need to figure out what those plants are supposed to be. And if those plants can be identified as Sidalcea in the last minute, then we can say that, Sidalcea will not be that endangered anymore. So maybe we can change our conservation purpose and strategies in the future. However, if those plants cannot be identified as Sidalcea, that means Sidalcea are really endangered or maybe already extinct. Because when we try to collect samples from the original location that Sidalcea located, we cannot find any of them, even we went to so many times. And people who work on the rare species there also said they haven't seen those populations for many years. So maybe we really need to focus on the conservation of the Sidalcea in the future. Also, if those populations could be identified as a new species, then it means, oh, we can improve our understanding of the diversity and taxonomy of the California flora in the future. So that's also another good thing. And to start with our project, we've tried to collect individuals that could be identified as either Sidalcea or Sidalcea diplocypha based on Jackson menu from as many locations and counties as we could. So finally, we got almost 250 individuals from 42 different locations within 10 counties. And this map roughly shows the distribution of all of our samples. And we also need to mention that although we didn't get any fresh materials for the true KKI in the southern Sierra Nevada, we did collect some leaf materials from the herbarium specimen that provided by the herbarium in the California State University in Fresno, which is pretty nice. And we also tried to check as many herbarium specimens as we could in both UC Berkeley Herbarium and the UC Davis Plant Diversity Center. For morphological analysis, we also download 8 sequences from the gene bank. And for the experimental methods, we basically focus on both morphological analysis and molecular analysis. And in the first step of our morphological analysis, we basically just focus on those morphological characters that mentioned as keys in Jackson menu to see if they work well or they just be useless. And I already mentioned that before, so I will not cover that again. And for the molecular methods, for molecular analysis, several individuals from different locations were selected in each county in order to cover as much genetic variation as we could. And we did several different morphological molecular analysis. And we got a bunch of results for the nuclear sequence analysis by using the ITS primers for amplification. We only got some preliminary data for the chloroplast sequence analysis by using tRNL primers. And we didn't get any results for microsatellite analysis for now. It's still in progress, but we are hoping that it could provide more proof for our hybridization hypothesis. So here comes some results. For morphological analysis, 100 individuals were checked in total. 60 of them were from the fresh materials that we collected, and 40 of them were the herbarium specimens in UC Berkeley. And we did find some very interesting morphological variation between those undefined Sidalcea and the other 2 species. So first, we found the variation in bracts division. As you can see clearly from the pictures, I hope, so the bracts in undefined Sidalcea, the bracts are usually more divided than the true Sidalcea in the southern Sierra Nevada foothills, but it's less divided than Sidalcea diplocypha. And the same trend was also found in the division of the upper pair stipules, where you can see in the true Sidalcea, the upper pair stipules are usually not undivided, while for undefined Sidalcea, they usually have either undivided upper pair stipules or one of the stipules is divided and another is not. But for Sidalcea diplocypha, they usually have 2 or more divided upper pair stipules. So from these 2 characters, we can see that, oh, maybe there's a support for the hybridization because they're usually kind of intermediate between these 2 species. And then we also found another morphological characters is in the variation in fruit inflorescence. Well, for Sidalcea and undefined Sidalcea, the fruit inflorescence are both not congested with visible axis, but for Sidalcea diplocypha, they already have congested for fruit inflorescence without any visible axis. I think the pictures are not really clear, but I checked many samples I could, and I'm pretty sure it's real. So After all of the morphological analysis, we are pretty sure that although those undefined Sidalcea are more similar to Sidalcea cachea, they did have some very unique morphological characters, and those characters are more intermediate between these two species, which might be a really strong evidence to say, oh, maybe these populations are just hybrid between these two species. However, when we look at the molecular data, a more clear relationship was found based on the nuclear ITS sequence analysis. So this is a parsimonious phylogenetic tree that we built based on the nuclear ITS sequence from 52 individuals. And 44 sequences were amplified from the individuals that we collected, and 8 sequences were downloaded from the gene bank. The numbers on the branches represent the bootstrap support value based on 500 replicates, just to make sure our tree is kind of reliable. And from this tree, we did see very clearly 3 distinct groups. The Sidalcea cachea from the southern Sierra Nevada, which was separated at the first place, and then the Sidalcea diplocipha and the undefined Sidalcea population from the North Coast ranges. And we can also see that the Sidalcea diplocipha did have a closer relationship with undefined Sidalcea population because they are separated afterward. And it's also interesting to see that Sidalcea diplocipha did have a distribution in North Coast ranges, and maybe that's one of the reasons why these two groups are more closely related to each other. And based on the ITS sequence analysis, we have more evidence to say that, oh, those undefined Sidalcea populations should belong to a new species, but we don't really know if this species is coming from either a hybrid origin from these two species or it just happened by chance. And we also found some genetic variation within the Sidalcea diplocipha population, like they have both Bibb County subgroup and San Mateo subgroup. And when we try to use chloroplast sequence to see if they have more clear relationship to support either hybridization hypothesis or a new species hypothesis, we didn't find any clue, because most of the individuals show clearly identical sequence in that area. But we did find some very interesting genetic variation within that area. So this is a UPGM tree that we built based on the chloroplast TRNL sequences. I didn't use this tree to show any phylogenetic relationship because it doesn't really make any sense. But I think it's a clear way to show you the interesting genetic variation that I found in the chloroplast sequence. So you can see those 3 individuals at the bottom, they both share the same nuclear insertion, which is really weird because they're supposed to belong to 2 different groups based on the ITS sequence analysis and morphological analysis. And they are sampled from 2 different counties. So it doesn't really make any sense based on both genetic basis and the geography distribution. So maybe those genetic variations just happen by chance, but it's not unusual in the TRN sequence. So I mean, we still need to try to figure that out by using the sequence from more individuals for sure in the future. And for microsatellite analysis, we only did several unlabeled microsatellite primer tests that work well for other species in Malvaceae family. So hopefully, when we're done with the microsatellite analysis, we're going to get a clear idea about the hybridization hypothesis. So from all of the results that we got, we are pretty sure that those undefined Sidalcea are more closely related to, but genetically different from Sidalcea diplocipha, and they did have some morphological similarity with Sidalcea cachea. And it's highly possible that those undefined Sidalcea populations belong to a new species. So we still need to do a lot of future work first. We have to figure out those really weird genetic variation within the chloroplast sequence by using more individuals. And we need to finish our microsatellite analysis to figure out the hybridization hypothesis. We will also try to explore more morphological characters by using more individuals, both fresh materials and prepared materials. Maybe we can find more morphological variations such as polymorph morphology or the density of the granular hairs or something like that. So finally, I really want to thank all the people who helped me during this project, and I want to thank Northern California botanists who gave me this chance to present my research, and I want to thank my car for taking me everywhere for my samples. It's really helpful. So thank you so much for listening.